Now the third company, Aquanos. It's not going to work, okay?
Yeah, too complicated, I see. Hi, good afternoon, everybody. My name is Leshem. I'm the CEO or co-founder of Aquanos. Aquanos is a company that developed a unique wastewater treatment system. And wastewater, everybody hear me, by the way? Because I like to walk around when I'm talking and also talk with them.
The people watching you.
Okay, so I need to be here. So wastewater is a big, well, I can see it here as well. That's very sophisticated. So wastewater is a big problem. Just to give you a sense, average person in the United States produces 265 liters per day. That's equal to 176 bottles of mineral water that you have to take out of the house and purify. Now, this wastewater, when they're being treated, and unfortunately still most of the world does not enjoy a good quality of wastewater treatment, are being sent to wastewater treatment plants. In these wastewater treatment plants, this water are being purified and then either reused, as being commonly done in Israel, or being safely discharged to the environment. Inside the wastewater treatment plants, we use naturally occurring microorganisms to degrade the pollutants that are in the water. Now, these microorganisms, in a very similar manner to ours, are consuming oxygen for their activity. So oxygen supply into the water become the key parameter in wastewater treatment. Now, there's many ways to provide air inside the water. Air contains the oxygen, but all of them are based on forced aeration, which means we have to push huge amount of air into the water. And pushing this air consumes huge amount of energy. So energy, right, is the single largest expenditure in wastewater treatment. Just to give you a sense, 5% of electrical consumption in the United States or any other place in the developed world is going towards wastewater treatment. And if you think about it, what we're doing, if I'm really oversimplifying the process, we're trading one environmental problem, which is polluted water, to another environmental problem, which is air pollution. Can it be done in a different manner, in a more sustainable, in a more economical manner? Obviously it can, otherwise I wouldn't ask this question. And the answer is algae. Why algae? Algae is an aquatic plant, right? Like any other plant, it does photosynthesis, which means it takes carbon dioxide and produces oxygen. Now, traditionally, people try to use algae as the oxygen source for wastewater treatment in a very large lagoons, where they have both the microorganisms and the algae in the same reactor. The end result was a very inefficient process which required large footprint and produced low quality of water. And here exactly comes the Aquanos process. What we're doing in the process, we're separating the process into two separate zones. And you have to excuse me, I have to show on the board. One, we have aerobic fixed room. Why fixed? Because we fix the microorganism into a media. The other one, we have an algae pond, which is engineered to grow algae. So here we have the consumer, which is the microorganism, who are degrading the pollution out of the water. And here we have the algae who are producing oxygen. All we have to do is pump the water from here to the microorganism, to the consumers, who are then cleaning the water. Next stage is solid separation, where we harvest the algae out of the water. And then we have clean effluent. So the end result, we can produce high effluent quality, but with 90% energy reduction when you compare it to traditional processes. It's not 100% because we still need some pumping, but it's 90% reduction. We also get a big reduction in capex because building this algae pond, which is the main source for oxygen, is a very cheap process to do, and it's a very simple and robust process. But aside from saving, right, the energy and reducing the capex and producing clear water for reuse, we also have the algae that we harvest from the water. And this algae containing a lot of nitrogen, a lot of phosphorus, and a lot of lipids, depends how you design it. So you can do resource harvesting. Okay? So not only clean the water, but extract the resources out of the water and use them to either produce fertilizers, animal feeds, or even biofuels in the water in the future. Just a little bit of where we stand, just to save the question afterwards. Been in operation for 2 years. We've done the proof of concept on a side stream in a Recanati wastewater treatment plant. We got our first seed investment from our strategic partner in the United States. We're currently operating a beta site in the Dan region wastewater treatment plant. Everybody is welcome to see. And we have a PCT standing for process. Just a little bit about the team. It's my co-founder, my Frederic Blanc, both, and myself, one I don't recognize. Both have an MSc, are environmental science or environmental engineers, have a large experience in all aspects of the industry, from engineering to constructions, operations of wastewater treatment plants, both in Israel and globally.
Right on time. Questions? Yes?
Is there any issue with the choice of algae?
With the sorry?
Choice of algae, type of algae?
That's a very, very good question. What we started the system, we started with Scanadesmus, if you're familiar with different types of algae. Now, there's been a lot of money invested in the last few years trying to grow algae for biofuels. We're trying to grow algae for oxygen. So from our point of view, right, just to do the process, we don't care what kind of algae as long as it does photosynthesis. So we started with one seed, we knew, and that's exactly what happened, that the local endemic species is going to take over. Okay, so we don't care. Now, if you're talking about growing it for biofuels, then you want to have maybe a specific algae. But we know for sure for biofertilizer, bioplastics, they don't care what's the type of algae inside.
Is your revenue, two questions. One,
Sure.
your expectations of efficiency, is that calculated or is there any proof in the...
They're both calculated, again, based on our 20 years of experience in the industry, and based on our pilot plant. So pilot plant, we know we produce we need 0.12 kilowatt hour per cubic meter. It's probably going to be much better on the larger scale because unlike other things, it's much harder to run and operate a small pilot plant in our industry than a larger one. If you look about textbooks and what's typical, that's between 0.5 to 0.6 kilowatt hour per cubic meter. So it's been proven in the pilot.
And just one more, and is your output, would you make more revenues from the algae or from the water? What's your expectation? Because you're selling water, clean water.
It's a wastewater technology with a side benefit, not the other way around.
Essentially, the question is, what's the business model? What are you planning to actually sell?
Right. So what we're selling the technology. So we're technology companies, work with global partners. Okay. So we don't want to take the entire world at a time, but we're focusing mainly on developing countries at the beginning, just because we're looking from an infrastructure point of view. The main market right now is developing countries. They're building much more wastewater treatment plants now in India than they're doing in the United States. What are we selling? Sorry?
License technology or sell plants?
We don't sell the entire plant, but we sell key components, okay, to an EPC company who built the plant. Okay? There might be some market when we decide to license. Maybe we don't want to focus there. We're limited resources, so we're just going to give you a license and you're going to do it. But on our key markets, we're going to sell key components to partners.
What have you been, your lessons learned from the pilot?
What are lessons learned? Well, first of all, it's easier than we thought in one sense, especially the algae part. I hope there's Ranan, I'm sorry. It's not as complicated as they said, especially if you don't try to grow a specific type of algae. So I can show some more pictures about, we had like photobioreactors. We thought we will need to keep acclimating the algae. It was very, very easy to operate the algae. So that was the positive sign that we learned. The negative sign, we thought that solid separation is going to be easier than it actually turned out to be, but we think we have the solution now. Because separating the algae from the water is a little bit more tricky than we thought it would be.
And the retention time?
24 hours.
Yeah.
Do your calculations take into account energy invested for the solid separation?
Yeah, everything from A to C.
And is that a proprietary part of your, are you going to have proprietary IP on the solid separation, or is it
No.
just invested class?
No. Our IP lies in the process, just on this process. We don't take IP not on the solid separation. We're also going to use anaerobic digestion prior to generate energy. It's one of the resources we recover. And again, that's not something, not special IP, at least for now.
And are you going to be targeting retrofit opportunities initially, or are you going to be targeting new?
We're going to target new, yeah, mainly new. There's some retrofit, but not on a, what's called intensive. Sorry, Jack knows the market a little bit better. So, and not on intensive, but more on extensive system. We can retrofit the market, but there's huge market right now, as I said, especially in the developing world, for greenfield application.
One last question. And the quality of the water?
Meets what standards you want. So we can design a system, usually the Israeli standard, and it's quite typical, you know, it's not something, talking about 2030 in terms of BOD TSS, that's like the basic standard. Then you can do nitrogen removal or you can do tertiary. So we design a system according to local regulation. We can meet all standards.
Thank you very much.